Hello everyone, welcome back to Energy Vision. In our previous videos, we discussed metal displacement, open end displacement, and close end displacement. We also calculated these values using formulas and learned how to calculate the displacement for one stand and 5 stands of drill pipe. Today's video is the final part of the tripping series. In this video, I will show you how to prepare a trip sheet in Excel format using real field examples so you can understand it easily. At the end of the video, we will compare our prepared trip sheet with an actual field trip sheet. Before running hole, we need the BHA, bottom hole assembly, and the pipe tally. The BHA includes different tools used while running in hole, such as the bit, butt motor, stabilizers, drilling jars, drill collars, and heavyweight drill pipes. To prepare a proper trip sheet, we need to calculate the displacement of each component. However, in today's video, we will calculate displacement only for drill pipes, otherwise the video length will become too long. The rig manager or tool pusher will provide the BHA details and pipe tally at the rig side. Now, let's open the pipe tally and check the OD, ID and average length of the drill pipe. Our drill pipe OD is 5.5 inches, ID is 4.778 inches and the average length is 95 feet. In our previous video, we already calculated the open end and close end displacement for one stand and 5 stands. Now in this Excel file, the first column is start stand number. The second column is finish stand number. In the first column, we will write the starting stand number, and in the second column, we will write the stand number at which we take the trip tank reading. For example, while starting running hole, we write 0 in the first column and 5 in the second column because we take the trip tank value after 5 stands. In the third column, we will enter the trip tank value. This value is recorded before running hole and then after every 5 stands. In the fourth column, we will enter the actual displacement, which we calculate and record after every 5 stands. In the next column, we will enter the theoretical displacement. The theoretical displacement we calculated in our previous video is 13.91 barrels. This is close end displacement because we have a fruit valve in our BHA. Next, we will create a column for fill up or transfer trip tank because during tripping we fill up the trip tank and also transfer the trip tank volume to the pit systems. In the following column, we will mention loss or gain so we can monitor how much loss or gain occurs over the last 5 stands. After that, we will add a cumulative column which helps us track the total loss or gain from the beginning. In the last column, we will write remarks where we mention details after fill up or transfer operations. Now, let's move on to filling the trip sheet. In this picture, you can see the blue curve increasing after every stand, the green line showing the hook position. To fill the trip sheet, we first need the initial value, which is the trip tank reading before starting running hole. So, in this graph, our starting trip tank value is 11.4 barrel. The value increases after every stand while running hole. I will take the first value and enter it into our trip sheet. Now we will take the trip tank value after 5 stands according to the graph. The value is 25.22, so we will enter this in the first row. Next, we will calculate the actual displacement using the formula. So 25.22 minus 11.40 is equal to 13.8 barrel. So our actual displacement is 13.8 barrel. Now I will drag this formula down so it will calculate automatically for the next rows. Now let's move to theoretical displacement column. The theoretical displacement was already calculated in our previous video. If you haven't watched that video, I will share the link in the description. In the next column, we will enter values whenever we fill up or transfer the trip tank. After each operation, we will mention how much volume was filled or transferred. Now, in loss gain column, we will apply a formula to monitor the loss or gain for the last 5 stands. For running hole, the formula is actual displacement minus theoretical displacement. We will drag this formula so it calculates automatically in the next rows. As we can see, the loss gain value for the last 5 stand is stable and we do not observe any loss or gain. This confirms that our well is stable. Next, we move to the cumulative column. This column shows the total loss or gain from the beginning to the current point. We will apply the formula here and drag it to calculate automatically. In the last column, we will add remarks such as fill up trip tank, transfer trip tank, fill up string, circulation. The remarks depend on the operation performed. Now our running hole trip sheet is ready. We just need to enter the values. Let's enter the value after 10 stands. From the graph, the trip tank value at the 10th stand is 39 barrel. So we will enter 39 in the trip tank column. You can see that all values are now calculating automatically and there is no gain or loss. Just for checking, if I enter 49 instead of 39, let's see what happens. Now we can see a gain of 10 barrel in the last 5 stands. This is how you prepare your running hole trip sheet. Now let's compare it with a real field trip sheet. This is an actual field trip sheet and it is exactly the same as the one we prepared. You can also see remarks such as empty trip tank mentioned in the remarks column. If you want to practice, you can pause this video and prepare the trip sheet along with me. Now let's talk about how to prepare a pull out of fall trip sheet. First, remember one important point. During pull out of fall, we normally use open end displacement, except in special conditions. As calculated in our previous video, open end displacement of one stand is equal to 0.69 barrel and open end displacement of 5 stand is equal to 3.46 barrel. We will use these values in our pull out of fall trip sheet. Since the drill pipes are already in the hole during pull out of fall, we count the stands in reverse order. For example, if the total number of stands as per the tally is 100 and we pull out 5 stands, the finished stand number will be 95. We will enter 95 and break the formula. All other columns will remain the same as running hole. Now let's open the pull out of fall trip tank graph. In this graph, we can clearly see that the trip tank volume decreases gradually during pull out of fall. For better understanding, I have marked the stand numbers from 1 to 10. The initial trip tank value is 45.04 barrel, so we will enter this in the pull out of fall trip sheet. After 5 stands, the trip tank value is 41.69 barrel, so we will enter this value. Now calculate the actual displacement. 45.04 minus 41.69 is equal to 3. barrel. So our theoretical displacement is 3.46 barrel. Now remember one important rule. For running hole, always minus theoretical displacement from actual displacement. And for pull out of fall, always minus actual displacement from theoretical displacement. This keeps the loss gain value correct. After applying the formula, our loss gain value is approximately 0.1 barrel. The cumulative value will automatically calculate in the next column. Now let's enter the trip tank value after 10 stands pull out of fall. The value is 38.34 barrel. After dragging the formulas, we can see that the trip sheet is stable and we do not observe any gain or loss. While drilling, if drilling supervisor or company man asks about the trip sheet, we can confidently say that the well is stable and there is no gain or loss. Now we will compare our trip sheet with the real field trip sheet. Now you can see both sheets are perfectly matching. With this explanation, You should now be able to prepare a trip sheet confidently in real field conditions. My goal was to make this topic as simple and practical as possible. If you have any questions or face any confusion, feel free to ask in the comments and I will make sure to guide you clearly. If this video added value to your learning, please subscribe, like, share, and enable the bell icon for future updates. Thank you for watching.